Today we are discussing about the mechanical modeling. This is all about the translational motion. Now we are learning the difference between the translational and rotational. In this, translational will represented by force, and in rotational, force is represented by torque T. In the translational motion, we represent displacement by x, and in this will represent angular displacement. Okay, angular displacement is represented by theta. Here will represent velocity, that is dx by dt is equal to v, and here we are representing angular velocity by omega, that is d theta by dt. Note down this thing. The way we studied for the translational motion, similarly we'll study for the rotational motion, right? So for the rotational motion, as I told you, there is inertia that is denoted by g. So if I'll rotate this j by an angle theta, what would be the equation for the torque? That is j d2 theta by dt square. Okay, it is inertia. Next one we are having for the damper. Damper, again torque is applied and it displaces its angle. Okay, here it displaces by theta 1 and here it displaces by theta 2. So in this case the torque equation is B for the damper, d by dt of theta 1 minus theta 2, that is for damper, correct? Similarly we'll have spring, that is denoted by K. Again it will rotate theta 1 theta 2, so torque equation is K into theta 1 minus theta 2, that is spring constant. Okay, understood? Now I'm teaching according to your PDF. Okay, now in this, as they said, translational, or we can say linear motion, it will includes following terms, that is displacement. Okay, displacement means movement, velocity, at how much velocity it is moving. Okay, then acceleration, acceleration is the change of velocity with respect to time, then force, correct? Displacement is denoted by x of t. It is a function of time because displacement can change from time to time, right? Velocity is denoted by v of t, and v of t is equal to differentiation of the displacement. There is a relation between displacement and velocity. Similarly, acceleration is denoted by a of t and its relation is dv of t by dt. Okay, and force you know. So basically in the mechanical system we'll have a spring like this. This is known as linear spring. Okay, this is known as linear spring, is used to model any component in the system that has its elasticity, right? You know, spring has its elasticity and it is denoted by K, and coefficient of stiffness of elasticity is denoted by K. Understood? And its unit is Newton per meter. Got it? Linear motion is also consist of friction, right? If there is a motion, then obviously then there would be friction, correct? So friction is the retarding force directly proportional to the linear velocity, and in this friction is denoted by like this B, and its unit is Newton meter per second. Okay, now suppose if you'll have a system, like suppose this is a fixed point, okay, and through the fixed point they have connected damper like this, they have connected spring like this, and then both the things are connected with the mass like this. Okay, understood this point, that this is the damper like this. So as you know, damper or friction is denoted by B, this is spring denoted by K, this is mass, and we are applying force F of T over here, right? If we are applying force in this direction, obviously then mass will move in this direction, right or not? So displacement is x of t. So let us assume that we have a mechanical system such like that. Then see how can we determine the transfer function that relates to the output displacement. Output displacement, this is one is the output because it moves, and what we have provided input is the force, right? Because we are applying a force on the mass, then what would be the output? It moves away from its original position, correct? Understood? So now in this case they can ask you to calculate the transfer function, and transfer function is always output divided by the input. Okay, understood? Clear? Now we have to follow the certain rules for the calculation of transfer function. We have to, step number 1, determine whether each parallel section of spring or dashpot. You know what is dashpot? Or you can call it as dashpot or you can call it as damper. It's one and the same thing. Is extended or compressed. First of all, we need to determine that, as you can see, these two sections are parallel, right? These two sections are parallel, so we need to learn about it, whether that it's a extended or a compressed, right? Now see how can we determine. Suppose we'll have a fixed point like this and spring is like this. If the spring displacement is like this, like if we'll extend the spring, if the movement is like this, then it is x of t, right? So in this case the spring would be extended, correct? And if there is a fixed point, the same and the same position of the spring, then if but we are applying a force on from above like this, F of t, so movement is also on the downward side, so it would be y of t. So this is the case of compressed, right? Here the force is moving in the upward direction, so spring is extended. Here the force is in the downward direction, so spring is this one, right? This is the case where one end is moving and other end is fixed, right? This end is fixed and other end is moving, correct? So in this case, equation would be f of t would be equal to k into x of t, right? Similarly, in this case, equation would be f of t is equal to k y of t, right? Understood? So this is the case. Now if suppose both ends are moving, okay, there is no fixed point. Suppose this is the spring. Here for the above case, force is moving upward, so displacement is upward, right? In this case also displacement is upward, right? So in this case the spring is extended, right? If we are moving force in the spring upward side, then it would be extended, right? So it would be F is equal to K into X of t minus Y of t, right? Now there is next case. If suppose force is moving in the downward direction, okay, then obviously displacement is also in the downward direction, right? So if it's in the downward direction, then it would be compressed. So that would be F is equal to K into X of t minus Y of t. So if it is moving upward, then extended. If it is moving downward, then compressed. Similar, upward extended, downward compressed. Now as you can see that it is moving like this. So mass is moving like this. So a spring is moving like this. So this is the case of extended or compressed. Compressed because it is moving in inwards direction. Understood? Now see, based on the question, we got to know that spring is compressed. Now we learn about the damper or dashpot also, whether it's a extended or compressed, right? So now dashpot or damper, suppose we'll have fixed points, okay, and we'll have damper like this, and it is connected to the fixed point, and suppose force is moving upwards, okay, force is moving upward, then in that case displacement is also upward, right? So this is the case of extended, correct? So in this case force formula is F is equal to B into dx of t divided by dt. Now the another case is that if it is one point is this one and dashpot is like this, then force is on the opposite side, means downward side, right? Then in that case obviously then displacement is also on the downward side, so in this case it is compressed. So it would be F is equal to B dy of t by dt. So if it is moving upward, then it is extended, right? And if it is moving downward, then it would be compressed, correct? Now if both the ends are moving, right? So if both the ends are moving, if the force is moving on the upward side, that would be F of t, that is X of t. Displacement is upward, here also displacement would be upward. So in this case F is equal to B into d by dt of X of t minus Y of t, okay? Now again the opposite case, here suppose damper is there. If the force is moving in the downward position, then two displacement both are in the downward side. So this is the case of extended and this is the case of compressed, right? So it would be F is equal to B into dx of t minus Y of t divided by dt. Understood? Correct? Now last one is for mass. If suppose we are having mass, if it is force is in the downward position, okay, then displacement is also in the downward position. then it would be F is equal to m into d2x by dt square, right? If force is in the upward position and displacement is also on the upward position, then in that case F is equal to m into d2y by square, right? Note down this thing also. Now back to the question. Okay, we have specified, now we know which one is compressed. This case is compressed, right? Because it is moving inwards, so this is compressed, correct? This is also compressed, right? And input force is moving like this, so this one is the compressed case, correct? Now step number 2, since one end of the spring and dashboard is connected to a fixed point, right? So in this case the compression of the section is equal to the movement of the other end, correct? The compression is equal to the movement, correct? Because if one point is fixed, right? So in this case, now the step number 3, the next step is to draw the direction of the internal reaction in all the component. Therefore we need to draw the mark the direction, okay, correct? So if I mark the direction over here, then it would be, one is like this, wait, one is like, right, this one is like this, correct? To every opposite reaction it will appear the force like this, right? And force is like this, so this is like this, correct? Now for the fixed point it is moving the force in that direction, right? So if I want to make the equation from here, then see, the equation is f of t is equal to m into 2x of t by dt square plus b dx of t by dt plus k x of t, right? Understood? Now if we want to convert it into Laplace, like I'm writing down this equation over here, f of m d2x by dt square plus b dx of t by dt plus kx of t. If we want to convert it into Laplace, you know na, Laplace transform will convert it from t domain to s domain, right? So it would be m, if it is the double differentiation, so s square x of s, correct, plus b, it is the single differentiation, so s into x of s, there is no differentiation, so k into x of s, correct, and force will be f of s, right? If I'll take the f x of s common, then it would be, what would be the m s square plus bs plus k, right? So from here can we get x of s divided by f of s, that is 1 divided by ms square plus bs plus, so this is the transfer function which they want from us. This is our final answer. Got it?